In this problem, we're trying to determine the delta H for a specific reaction, and it tells me the reaction balanced with the lowest whole number ratios. So what is that reaction? The reaction is between aluminum, so Al, and chlorine, so it's reacting with Cl2 to produce AlCl3. Now that is the formula for aluminum chloride. And if we balanced it, we're going to put a 2 here, a 3 here. That'll give me 6 of the chlorines, and I'll need a 2 here. So this is the lowest possible whole numbers you can use to balance this reaction. And we're trying to determine the delta H of this reaction. Okay, so we look up here, and somebody collected some data for us. They determined that if you took 12.5 grams of aluminum, so I have 12.5 grams of this, and reacted it with an excess of the chlorine, okay? When that happens, we would be able to produce 346.3 kilojoules of heat. So we have a ratio given to us, 346.3 kilojoules for every 12.5 grams of aluminum. We know that, and since it's produced, we would have a minus sign. It's exothermic. But we don't want to know it for 12.4 grams, 5 grams. We want to know it for 2 moles of aluminum. So we take the 2 moles of aluminum, and we first convert moles of aluminum to grams of aluminum, because if we can do that, we are able to use this relationship here that we were given by the problem up here. So we were given this information. We'll be able to use that information to get the final delta H for the reaction as balanced. So what's the molar mass of aluminum? It's 26.98 grams in a mole. And then we can use a relationship from grams of aluminum to kilojoules, put a negative 346.3 kilojoules there, and 12.5 grams of aluminum there. And that will give me 1,000, and it's actually negative, 1,495 kilojoules. And that would be the delta H, negative 1495 kilojoules. Now this is one way to do it, and I'll put a number 1 here. There's another way to do this. It's the same process, and you can just kind of choose which one you'd prefer. If you know the relationship of kilojoules per 12.5 grams of aluminum, you could say, well, I need a relationship per moles of aluminum, not per gram. So you could say, I don't want grams, so I'll put that up here. I do want moles, I'll put that down here. And the molar mass of aluminum is 26.98 grams per mole. And that will give you the amount per mole. And then you'd say, well, I don't need it for 1 mole. As I look at my balanced equation, I need it for 2 moles. So then you would multiply by 2 moles, and that would still give you the same number. So it doesn't matter in this case which way you want to think about it. I generally don't start with a conversion factor, the relationship between kilojoules and grams, when I'm doing dimensional analysis. But since you're trying to get how much heat for a specific amount, you could start with this and then change this denominator to moles, and then realize that you don't need it for 1 mole. This is the step that people would often forget. You need it, according to the balanced equation, for 2 moles.